example over here, and an important part to note down about a square is that a square is a shape which has the same amount of just length of the sides are the same, so the length and the width of the square is the same, and for this very reason we will be trying to map in this particular question the difference between the sides on the length and the width and checking when they can be equal. So what I am suggesting we do is start at 1 and see the difference between 1 and 2, so that is 1. And then again the difference between 1 and 4, which is 3, the difference between 1 and 7, which is 6, the difference between 1 and 8, which is 7, and so on and so forth. We have to do the same for 2, we have to do the same for 4. So we just keep going on in this pattern. So difference between 2 and 4 is 2, difference between 2 and 7 is 5, difference between 2 and 8 is 6. So we're going to store all of these values in a memory location, and we'll just try to compare at what point the length and width difference is going to be equal. So if I remove the 2, suppose, then I will have the distance between 1 and 4, so that is 3. So we'll have to see at what point will this length column also be equal to 3, right? So this problem is not very like mathsy or intuitive, it's just a basic comparison and for loops, and yeah, I think we should just directly get into it if you understand the question. So I will try and code the question for us now. I am not very sure if it is clearly understood, but what I'm trying to do is calculate the difference between the fence and the first point and the fence and the second point, and just keep doing that again and again until I get the differences for everything. So when I remove 3, then I have 1 and 5. So I'll need to have the difference between 1 and 5, that's 4. And I'll have to have the difference between 1 and 6, that's 5. And see if it matches any difference over here. So if I see 2 and 7 removed, will give me the difference between 1 and 5, and that will give me the square. Right, so let us get into the coding. An important part to note here is that edge fences only has 2 and V fences only has 4, but we also need 1 and 6 in it to be able to calculate our differences. So first off, I will go about and add. So I will take edge fences dot append 1. I'll go about and really quickly copy that. Fences dot append M, right? Because M is the horizontal one, and then V fences dot append 1, and V fences dot append N, because vertical fences are N, right? So, yeah, alright. Now another important thing that we learned from yesterday's question is the fact that you have to sort your HMV fences. So I'll just quickly do that, so that just in case if something is not in order, we have to make sure it is. Another important part by doing this question is if your value gets really huge, then it will not fall into the integer solution that your laptop or your computer calculates in. So we have to store the number of integer bits that your computer or desktop will calculate and basically mod the final value by that, because your answer will come out to be extremely large and that integer value will not be displayed correctly using your desktop or your screen. So From there on, what do? We just keep calculating the difference. So for I in range, let's start by M if you please. For J in range, I to adjust 1 to M. So M is the horizontal one. Just what are we trying to do now? We're trying to calculate the difference. So I'll make sets because I want to get my values in O of 1. So let us make H set and B set. So that is my H set and B set. Now for I in range M, for J in range 1 plus I plus 1 and M. This will be my horizontal set. Dot add. You have to do dot add here because sets do not have appends, they have adds. Of course, I don't know if you know this, that's why I'm specifying it separately. Now we do expenses and expenses J minus expenses I. So you are storing the difference of these both in the set. So why are we using set? Because firstly, if you can see here, there might be multiple values that will repeat, like 6 repeated here. So my set will ensure that similar values, recurring values are not added to the set because we really just bother about the difference between the 2 points and not which 2 points are being considered. And secondly, because sets search in time complexity of O of 1, they do not search O of n, but if I use an array, it would obviously be O of n because I did it to every element. So that is another reason and major reason why we're choosing set. Now we just do the same thing for defenses. Now V is the vertical ones, right? I have made a V set, so V set dot add, you add the difference. I'll just copy this really quick because it is a big term to write down all the time, but yeah. J minus, we have already sorted, so we always know that the second element is going to be bigger than the first element, so that is a relief. Alright, so that is done. Now moving on from there, we will do a max common value is equal to 0. So what we will do next is the max common is 0. We have to check basically for D in H set if D in V set. So basically that so we'll have to basically see if they have any similar because as we discussed earlier, we should have the length and the width to be same in a square, right? So I can only form a square here with 2 to 7 and 1 to 5. So the difference between these both is the same, right? So that is what I'll be doing here now. I'm storing the maximum difference that is same in the two of these sets. Now if alpha is equal to 0, return -1 and c will return max common whole square modulo is our password. Now we will try to submit this, see if we have made errors somewhere. We have not to the best of my knowledge, but we will have to see. Expenses out of range, okay. M is horizontal, right? And as vertical, okay. Okay, so I think this could have something to do with for I in range M, for J in range I plus 1. I feel like because we have given our value to be because we have given our value to be I plus 1, that could cause this kind of problem. So how do we resolve this problem that has occurred here? What we can easily do is just set up a check condition, right? So what do we do if our I is if our I is equal to let's say n, right? So in that case we can skip that iteration. I hope that makes sense. Yeah. Or we can just do this. In fact, I think it is better to do the length because, okay, right. So the problem here is that my m and this isn't the, sorry, my bad. So here we have to do length of, it's not m, it is length of expenses. Yeah, my bad. And here again we have length expenses. Similarly here, because n is a mass number, I have to understand what my mistake was. And this n is because m and n are not the number of components in expenses and expenses, rather it is just the number of parts that are present, right? So that can be a problem. So we have tried to solve this now. And okay, so this has gotten accepted here, but of course it should get accepted overall, so we can check that. So yeah, our solution works, and it is not the most efficient way to do this, I feel, but this definitely works, and you can try doing it another way, and please let me know if I can solve it in a better way.